Welcome back again to our next session. So in this session we are going to discuss about what should be the configuration of control IO or control register. Okay, so we know there are mainly two types of mode. One is bit set reset mode and another one is IO mode. In IO mode there are three modes. One is mode 0, 1 and 2. So for bit set reset mode, just a review of last session, the MSB should be 0 for bit set reset mode. Okay, and for IO mode it should be 1. Okay, so since we are discussing about modes bit set reset mode, MSB, that means D7 should be 0. And next 3 bit is don't care. And these 3 bit will be used for selecting the pin of port C, and this will be used for set or reset. Okay, so you can see by this word format, D0 is for set or reset, then D1, 2, 3 is for configuring the pin number or selecting the pin number, and next 3 bits are don't care, and the last bit D7 is for selecting the mode, whether it is set reset or IO mode. So here this is 0 and it's in IO mode. Okay, so we also have seen on last class, like first two, port A and port B is not going to work. Only one bit or only one pin of port C will be either set or reset. Okay, here are two examples. One is if we want to set PC3, then that should be our control register, or in vice versa. If we put this information to the control register, from next time we will get PC3 set. Okay, and the same thing for PC4. If we set this control word in the control register, then from next we will get PC4 reset. Okay, now once again I am reminding you, before performing IO operation, first we have to configure the control word. That means if we want to have something in our ports, before any of IO operation, first this control register should be configured. Okay, then we will be able to use this port. Okay, so in this figure is showing, first we have to write on the control register, and then we will be able to have the IO operation. Okay, keep in your mind, once again, this is very important. We want to have some IO operation on different port of 82C55. Before doing that IO operation, we have to configure the control word first. Okay, like if you want to use one keyboard, one printer in one 82C55, so first we have taken this decision, like we want to use that printer and keyboard on these ports. So according to that decision, we have to set the control word or configure the control word. Okay, that is the most important issue. Okay, so here is the IO operations format. Okay, what format? You can see D7 should be 1. Okay, for IO operation. We are now discussing about IO operation. So for IO operation, it should be 1. Okay, then next 2 is for, okay, this 4 bit is for group A, and this 3 is for group B, as we discussed on last class. and you can see here. So on group A, these two are for mode selection. This one is for port A, this one is for port C upper. Again, this one is for mode selection, this one is for port B, this is for port C lower. Okay, so this is the detailed pin configuration and the detailed discussion of 82655. Like we used 8-bit data bus buffer in the 82655 and also other two 8-bit buffered IO latch in port A and port B as we discussed on our last session, and 8-bit unlatched buffered IO and output latch on port C for normal IO operation, mode 0 operation. Okay, and of course there is a control register which is now blank. So now we'll take the decision, what are we going to do with this chip? Okay, our decision is like that. We would like to use 8 LED on port A, 8 LED on port B, and 8 switches on port C. Okay, so for doing this, we have to write according the control word. So we can write the control word very easily. Since group A is in mode 0, 0, 0. We'd like to use output device on port A, 0. We'd like to use input device in port C upper, 1. Group B is in mode 0. Okay. Port B will be used for output operation. Port C lower will be used for input operation. Okay. So we have to send this control word to the 82655 control register. Okay. So for doing this thing, you can see in the slide, write operation should be performed, and A0 and A1 will be 1, 1, since we are writing something to the from the MPU to the 82655. That's why A0 and A1 should be 1, 1, and other two things are okay. So after writing the control word, our control word will be like this. Okay. Now, after writing this control word, this IC is ready. This IC is ready. Okay, ready to perform the IO operation. Okay, next slide. Now, what is IO operation? In this time constraint or in this time span or at this moment, our microprocessor is sending a data to the port A so that we can blink or turn on some LEDs or turn off some LEDs. Okay, that means according to this data, port A will work. To perform this thing, you can see, is it read or write? Right. So WR should be 0. Okay. So which port we are going to use for this operation? Port A. So A0, A1 should be 0, 0. Do you understand? CS and reset will be remain same. Okay. But for port B, everything will be same. Just the data and A0, A1 will be different. For port A, A0, A1 was 0 and 0. But for port B, it should be 0 and 1. That is the difference between port A and port B. But data is depend on the microprocessor. Okay. So for port A was different data, port B is different data. Okay. In the same way, you can see data is coming from port C to our microprocessing unit. Okay. So to do this, our read signal should be activated. Okay. So our MPU will activate the read pin. Okay, for the 82655, and then deactivate or 1 in write. And of course, since we are selecting port C, A1 should be 1, A0 should be 0. If you will go back to the configuration, A0 and A1 configuration, you will find 1, 0 for port C. Okay, so this way we are reading something from port C to our microprocessing unit. Okay, now what happened in mode 1? If you want to use a printer in port A and a keyboard in port B, the same way First we have to send the control word for these, okay, to 82C55. So that is the control register, okay. And after sending this data or sending this control word to the control register, after that, after next clock cycle, or this system, in this system, we will be able to use printer and we will be able to use keyboard input B and printer input A. Okay? Keep in your mind, we have 3 ports, but we cannot use all these ports in the same clock cycle or in the same clock time. Okay? In one time, we can use port A. In one time, we can use port B. Like in this time, yes, we are writing something to the printer. So, WR signal should be activated. Okay? And it will send some data. Okay? And printer will receive the data. Okay? But in this configuration, in the same way, also we have to configure A0 and A1, 0, 0. Okay? And in the next figure, you can see if we want to write something, if we want to read something from keyboard, so its read signal should be activated and A0, A1 should be configured accordingly. Okay, so in this way, we can read something from the keyboard, and in this way, we can write something from microprocessor to the printer. Okay. Now, in mode 2, this is the same. Like for bidirectional operation, 5 pins are using for I/O. Okay, input output for port A. Once again, for port A, 5 pins are using as a control connection for handshaking bidirectional I/O operation. But for B, the same 3 pins are using for even in and out. Okay, 0, 1, 2. But for port A, different pins are using for this thing. Okay, so when we perform the I/O operation, we are going to discuss this thing with some time diagram on next session. Okay, thank you very much.